But not all masses of ice are glaciers. To qualify to be a glacier, ice must be at least 6/100 of a square mile in size and over 164 feet thick. Earth's largest glacier is Eastern Antarctica's Lambert Glacier, which is about 60. Glaciers form in places where snow accumulates over a long period of time. As the snow gets deeper, the resulting weight and pressure turns the bottom layers of snow into ice. Glaciers carve lakes and valleys and create riverbeds. The water that melts from a glacier's surface is the largest source of fresh water on the planet.
Fresh water is used for drinking, washing, food production, industrial activities, and to sustain ecosystems. Considering its importance, it's startling to realize how little fresh water is available to us worldwide. Our freshwater supplies depend on various sources such as rainwater, water stored in rivers, lakes and soil, treated wastewater, desalinated seawater, and groundwater. The global water demand is rapidly growing due to the world's growing population. Obviously, this increasing demand is also reflected in the use of groundwater.
Or this misconception that there's just this void space underneath the earth and that's where water is, and we just kind of stick almost like a straw down there and just get it out when we need it. But water doesn't exist that way underground.
The majority of groundwater is obtained from water stored within the microscopic spaces or pores in rocks or soil, just like the water in the spaces between these marbles. Groundwater is present nearly everywhere beneath the Earth's surface, even under the desert. But the volume of supply varies depending on the rock type, depth of water, and the land use above. Most groundwater comes from rainfall. When it rains, raindrops hit the ground. Some droplets are evaporated straight away or run off to streams and rivers. The remainder slowly filters into the pores and cracks in soils and rocks to become groundwater. It continues slowly downwards until it reaches in the pores between individual grains and particles. What do you think will happen when we fill this 10-litre container of sand with a further 3 litres of coloured water? If you thought the sand would absorb all the coloured water without the container overflowing, you were right. That's because the sand has pores that allow the water to be stored. However,
saturated zone, there are spaces in between whatever the grains are, sediment grains or
that
particles, that could be filled, but they aren't right now.
Yeah, and the water table.
Here's the water table. It's labeled pretty clearly for you. But what is the unsaturated zone then? It's the zone above that, and in this diagram...
Groundwater is always moving, and it varies in depth and volume according to the seasons. In winter, when there is usually more rain, the water table is higher than it is in the summer when rainfall is less. But just as our landscape is never perfectly flat, nor is the water table.
Unconfined aquifers. Groundwater contained in such aquifers is at pressures exceeding atmospheric pressure due to the overlying and underlying rocks. Such aquifers are called confined aquifers. The type of rock, its structure, and especially the openings within decide how much water the rock will store and how quickly it will allow it to flow from one point to another within the aquifer.
They can tell how much deep
So let's take a look at the key parts that make up a typical home water system. First is the well itself. The average well is about 200 feet deep, and most are drilled by specialized drilling equipment. Casing must always be placed in the top part of the drilled hole to prevent the risk of surface water getting into the well. Some wells use a well screen to let water in and to keep sand out of the well. A pump is needed to get water out of the well and into the home. Water from the aquifer is pumped from the well into a pressurized tank, which stores water for use when the pump is not running. From this distribution point, water is piped to individual use points in the home. The first step is proper planning. How much water is required to meet the needs of expected water usage in the home and garden? Where should the well be drilled? What well yield will we get? A well probably will need to be several hundreds of feet deep in order to provide adequate supply. But a well yielding as little as a half gallon a minute can still provide 700 gallons a day, more than enough for a family's needs. Today's water wells use modern technology to efficiently reach the aquifers. In rotary drilling, a drill bit is attached to a string of drill pipe. As the drill string is rotated, the bit acts as a grinding machine. Cuttings are flushed upward and out of the hole by circulating a special drilling fluid called drilling mud down through the drill pipe and back to the surface. This drilling fluid also serves to cool and lubricate the drill bit, and by stabilizing the wall of the hole, it can prevent possible cave-in before the casing is fitted into the hole. In areas of hard rocks, many drillers prefer to use a rig that operates by compressed air to operate a downhole air hammer to break up the hard rocks. The compressed air also blows the crushed rock fragments to the surface and any water that flows into the well during drilling. The hole is usually lined with steel or plastic pipe called well casing. The type of casing used is determined by local geological conditions and the chemical quality of the groundwater. In most states, there are recommended well construction standards. Diameter of the drilled hole is usually an inch or two wider than the diameter of the casing. The space between the drilled hole and the casing has to be filled to prevent surface water from migrating. A well screen probably will be needed. The well screen is a sieve or strainer-like cylinder attached to the bottom of the casing. It allows water to flow into the well while preventing fine rock particles or sand from entering. With the casing and well screen in place, a flushing or backwashing of the well may be performed to eliminate loose fragments and stabilize the area immediately adjacent to the well intake. This is called developing the well in the well. The electric motor turns impellers in the pump which cause water to be pushed upward out of the well. In some wells, especially in narrow diameter holes where the depth to water is less than 25 feet, a shallow well jet pump may be used. Above ground deep well jet pumps, also driven by electric motors, cause water to be pushed out of the well. Most home water systems include a water storage pressure tank. An important purpose of the pressure tank is to keep the supply of water to the home's taps and fixtures at a fairly even pressure. The pressure tank